Okay, problem number 12. Same directions. It says simplify if possible, show all work, assume all variables represent any positive real number. So once again, we still don't need to worry about absolute value symbols. Okay, this is an addition-subtraction problem, which means what we want to do is first simplify the radicals to their lowest forms and then see if there's any like terms. And if there are like terms, we would then combine them. So let's start doing that. The cube root of 320 breaks down to 64 times 5. 64 is the perfect cube and 5 is not. 40 breaks down to 8 times 5. 8 is the perfect cube and 5 is not. And then 135 breaks down to 27 times 5. 27 is a perfect cube and 5 is not. So we'll take the perfect cubes out, multiply them by the existing numbers in front, and then see if there's any like terms. So the cube root of 64 is 4. We're going to multiply it by the 3 that's already there, so we're going to get 12 cube root of 5. Bring down the minus sign. The cube root of 8 is 2, so that becomes 2 cube root of 5. The cube root of 27 is 3 multiplied by the negative 5 gives you negative 15 cube root of 5. Now that they're all simplified, you can see that they are all like terms because all of them are cube roots of 5. Remember, to be a like term, they have to have the same index, and these do, they're all cube roots, and the same radicand, means everything under the radical is also the same. And in this case it is, it's 5. So we'll collect the numbers in front. So 12 minus 2 is 10, minus 15 gives me a negative 5 cube root of 5. And that's the final answer. Okay, problem number 13. We're taking a quantity and squaring it. You can choose to do that individually just by raising each thing to the second power, or if you prefer, write it out twice. And remember, multiply the outside numbers together. So negative 5 times negative 5 is positive 25. Square root of 11 times square root of 11 is square root of 121. Well, that simplifies obviously to just 11, which would be 275. Okay, we'll keep going, and same directions. So still no absolute values if we have variables. Okay, we have a monomial term times a parenthesis, which we're talking about here happens to be a binomial. So remember, that means to distribute. And once again, when you distribute, you're following the rules of multiplication. So multiply the outer numbers together and the inner numbers together. So when I multiply the 8 square root of 7 times 7 square root of 14, I get 56 square root of 98. Okay, then the next term, 8 square root of 7 times positive 2 square root of 5 gives you positive 16 square root of 35. Okay, now you've got to simplify, if possible. Okay, square root of 98 we know breaks down to 49 times 2. 49 is the perfect square and 2 is not. And 35 doesn't have any perfect square factors in it. Its only factors are 135 or 7 and 5. None of them are perfect squares, so we'll just bring it down. Okay, so the square root of 49 is 7 multiplied by the 56 already there gives you 392 square roots of 2 plus 16 square root of 35. You cannot combine anything more. This is the final answer because, yes, they are both square roots, but their radicands are different. This is the square root of 2, while this is the square root of 35. You cannot combine them. This is your answer. Okay, problem number 15. Problem number 15 is a binomial times a binomial. And we know that that means for us to use FOIL. So first, outer, inner, last. So when I multiply the first terms together, that would be 7 times 7, and I get 49. And I'll bring that down here in red. Multiply the outer terms together. The 7 times the 6 square root of 5 is going to give you positive 42 square roots of 5. When I multiply the inner terms together, negative 3 square root of 5 times 7, I get negative 21 square root of 5. And then when I multiply the last terms together, I get negative 18 square root of 25. Now let's clean it up. Well, the square root of 25 is 5, so we'll multiply the 18 by the 5 and collect it with the 49 here. So that's going to give us negative 41. 49 minus 18 times 5 is negative 41. And these two terms are like terms because they're both square roots of 5. So 42 minus 21 square roots of 5 gives you positive 21 square roots of 5. And again, this is your final answer. You cannot combine these numbers because this has a square root of 5 and this does not. Okay, moving on, number 16. We have a radical of the fraction here. You've got it split up already. So would it help us to put it underneath one radical? If I put the square root of 5 over 18 under one radical, it would not simplify. You just have to separate it again, so it would not help us to do that. I could, however, go ahead and simplify the square root of 18 to the square root of 9 times 2, which of course then simplifies to 3 square roots of 2. You'll notice that we still have a radical in the denominator, and since it's a square root, that means just multiply top and bottom by itself and simplify. That gives me the square root of 10 over 3 square root of 4. Well, the square root of 4 is just 2, so I get the square root of 10 over 6 as my final answer.